Hi scholars, today we're continuing working with fractions on a number line. So let's start with our learning intention. Thoughtful mathematicians place whole number fractions and fractions between whole numbers on the number line. So go ahead and read these vocabulary words to yourself and pause to read them. Go ahead and pause again to read these. Press play when you're ready. All right, so let's get started with our lesson. So here we have an example. In today's lesson, we're going to estimate to equally partition and label the fractions on the number line. Then we're going to label the wholes as fractions and box them. So I have two examples here of how that would look. So that way when I model, it's not so confusing. This first one has halves, and I see it starts at 0 and it goes up to 2 wholes. So first I have at 0, 0 halves, and it's been boxed because that says box the wholes as fractions. Then I have 1 half, 2 halves, that makes 1 whole, so it's boxed again, 3 halves, and 4 halves, or halves, right? So I want to quickly explain why 2 wholes is equal to 4 halves. So I'm going to make 2 rectangles to represent wholes, right? So this is 1 whole, this is 2 wholes, so I have 2 wholes, right? And if I were to split them in half, each of them, I see that I have 1 half, 2 halves, that's 1 whole, 3 halves, 4 halves. So if I have 2 wholes and I split them each in half, that makes 4 halves. 1, 2, 3, 4 halves is equal to 2 wholes. So let's look at this other example. Instead of starting at 0, they started with 1 and moved on to 3. So number lines can really start wherever and end wherever. That's why they have these arrows pointing in opposite directions, meaning that they continue past what you see. So I start at 1, and this represents 3/3 because I remember that from my other lessons, anytime I have a numerator and denominator that are equal, that is 1 whole. 3/3 is 1 whole. So we're going to continue counting by thirds from here on. 3/3, 4/3, 5/3, 6/3 is equal to 2 wholes. That's why it's been boxed. Box my wholes as fractions. 7/3, 8/3, 9/3, and this 9/3 is boxed again because this represents 3 wholes. So notice every time I get to a multiple of the denominator, it is another whole. For example, 3/3, 6/3, 9/3. These are all multiples of 3, right? So 6 divided by 3 equals 2, that's why it's 2 wholes. 9 divided by 3 equals 3, that's why it's 3 wholes. So just some things to keep in mind as we do today's lessons to help you check your work. So let me model one for you. So again, I'm going to estimate to equally partition and label the fractions on the number line. And then I want to label the wholes as fractions and box them. So I have eighths here. This one's a little different because I'm just going from 2 to 3, so there's no middle. It's just 2 to 3. So I'm just going to make one set of eighths here because this is 1 whole. From 2 to 3, that's 1 whole. So I'm going to split this into 8 equal parts. Since it's an even number, I'm going to start in the middle. Then split this side into 4 parts by splitting in half, and then splitting it in half again. Do the same thing here. So this I want to split into 4 parts by splitting it in half, and then splitting those halves into half as well. Right? So I now have 1, 2, 3, 4, 5, 6, 7, 8. Good. We're ready. So now, again, this is 2. It's not 0, so I'm not going to have 0/8. I'm starting at 2 wholes. Well, I know that 1 whole is 8/8. So 2 wholes is going to be double that amount. So it's going to be 16 because double 8 is 16. So 16/8 is 2 wholes. Also 16 divided by 8 is 2, so I know I'm correct. So I'm going to count up by eighths until I get to 3 wholes. So after one more eighth would be 17/8, 18/8, 19/8, 20/8, 21/8, 22/8, 23/8. And here, my boxed whole as a fraction, 24/8. eighths. 24 divided by 8 is 3, so I know I'm correct. So I've now split this number line in eighths to represent 2 wholes to 3 wholes on a number line. So let's try one together. I want to represent halves from 3 to 5. So again, I'm going to do the same thing, estimate to partition equally, label the fractions of the number line, and label the wholes as fractions, and box them. So now, from 3 to 5, that's 2 wholes. So somewhere in the middle, I'm going to have to split this in half. But before I even start, I want to make sure that you guys are ready with me. If you don't have the materials you need, please go ahead and pause the video now, grab a piece of paper, somewhere to write, to do this with me, and I want you to draw your number line just like this with 3 at the beginning and 5 at the end. So pause now if you're not ready. Alright, welcome back. You should have your number line already drawn so that you can do what I do on my screen on your piece of paper. So if you're not ready, again, please pause now and draw your number line with 3 at the beginning and 5 at the end. So I have 3 to 5. I need 4 somewhere in the middle because 3, 4, 5, right? I'm missing a whole. So you're going to split this in the middle, and we're going to label it 4. Now in between these, we're going to have halves. Half, right? So we're going to split each whole in half. So from 3 to 4, we need another half. So go ahead and draw a half here, and then draw another half here. So please have what I have on my screen. You should have 3 at the beginning, 4 in the middle, 5 at the end, and then in between 3 and 4, a mark, and in between 4 and 5, a mark. I'm going to make this more even. So now from 3, actually let's start at 3, right? So now how many halves would make 3 wholes? Remember, 2 halves, 2 over 2 is 1 whole. We have 3 times as much this time. How much would that be? How much is 3 wholes in halves? So we're going to have 6 halves, or 6 halves, right? Because if I were to start with 1 whole, 2 wholes, and 3 wholes, and I split them all in half, 1 half, 2 half, 1 whole, 3 halves, 4 halves, 2 wholes, 5 halves, 6 halves, 3 wholes. So it's 6 halves, and it says to box all my wholes as fractions. So now we can move on. We're going to count by halves, continuing on from 6 halves, next would be 7 halves, then 8 halves, and I know I'm correct because 8 divided by 2 is 4, so go ahead and do this with me. If you don't have this already, go ahead and do what I'm doing. What would we have next after 8 halves? 9 halves. And lastly, what do we have over here at 5 wholes? How many halves would that be? 10 halves, and I know this is correct because 10 divided by 2 is 5, and we're going to go ahead and box this because remember it says to box the wholes as fractions. Right, so to recap, we started with splitting this here to represent 4 because we went from 3 to 5, but we were missing the whole number 4. Then we started at 3 wholes and went up by halves until we got to 5 wholes. 6 halves, 7 halves, 8 halves, 9 halves, 10 halves. Remember, halves is how you say more than 1 half, right? 1 is 1 half, but 2 would be 2 halves. That's the plural form of half. So that's all I'm saying when I say halves. So try this one. You're going to split these into fourths. So this one, they actually showed me the 3 in the middle, so I don't have to worry about drawing it on. But you can do the same thing we've been doing. Estimate to equally partition and label the fractions on the number line. Label the wholes as fractions and box them. So pause now, solve on your own, and then press play when you're ready. Again, pause now, press play when you're ready to solve or check your work. Okay, welcome back. So I have fourths on this number line, but that's what I'm trying to do. I have 2, 3, and 4 holes. So I'm starting at 2, I'm not starting at 0. So it's not going to be 0 fourths. It's actually going to be, fourths. 8 fourths. And I know that's true because 8 divided by 4 is 2. So I have 8 fourths. I'm going to box that. That's my first whole number. And I'm going to keep going until I get to 4 holes. But I can't continue because I haven't split my number line into fourths. So I almost forgot about that step. That's what I should have done first instead of starting with my whole. But it doesn't matter because I haven't done anything yet other than label this. So let's go ahead and split this into fourths. And I'm starting in the middle, correct? Because it's an even number and then I can split it evenly. So I have fourths on each side. Fourths here, fourths here. I can't do fourths from 2 to 3, right? Because that wouldn't be enough. This is one whole and this is another whole. So they each need fourths on each side. So now 8 fourths. Now I can go up by fourths. Next would be 9 fourths. 10 fourths. 11 fourths. 12 fourths. I'm gonna box this. This is my whole. 13 fourths. 14 fourths. 15 fourths. And 16 fourths at the end of my number line, which I will also box because that represents 4 holes. So to recap, I needed to have fourths on each side of the number 3 because from 2 to 3 that is one hole, and from 3 to 4 that is another hole. If we look back at the examples that I showed, from 0 to 1 we had halves, and from 1 to 2 we had halves, and the same thing for thirds. From 1 to 3 we had 3/3, and then from 2 to 3 we had 3/3. So in between each hole you need to have the fractional amount that they say, halves, thirds, fourths. For this one, this is the only one where I only had one group of eighths because it was only one whole. Well, for all the others, 2 groups of halves, 2 groups of halves, right? Whenever you have a whole number in between, you need to have the fractional amount. And what I mean by that is this is fourths, so I had 4 equal parts here, and then another separate 4 equal parts here, because it's from 2 to 3 is one whole, and from 3 to 4 is one whole. If you have any questions, please reach out to me on Schoology or Hangouts. Do not just guess. I want you to really understand how we place number lines, fractions on a number line. Thank you guys. Have a great day.